Hello friends, today our topic is the finding root for the algebraic and the transcendental equation. Now at first that video is for the introduction part, how to find the range of the root for any algebraic and the transcendental equation. Now at first, what is a root? The root of an equation. A real number small x is said a solution or a root if it satisfies the algebraic or the transcendental equation. So a linear equation ax plus b is equal to 0 has one root because the variable x has the power only 1. Suppose a quadratic equation ax square plus bx plus c where a is not equal to 0 has two roots because x the variable has the power as 2. A n power equation, that means Pn x to the power n plus Pn minus 1 x to the power n minus 1 up to P0 is equal to 0 has n roots. Why? Because the variable x has the power n. So when we are talking about the root of an algebraic equation and the transcendental equation, then what is the meaning of the algebraic equation? Now the algebraic equation can be defined as a mathematical statement. Once again, as a mathematical statement in which two expressions are set equal to each other. In simple words, equations means equality. Equations means equality. That is the equal sign. That's what equations are all about. Equating one quantity with another. The polynomial equation formed with variables. Linear equation like ax plus b is equal to c where a is not equal to 0. The quadratic equation such as ax square plus bx plus c is equal to 0 where a is not equal to 0. Cubic equation ax cube plus bx square plus cx plus d is equal to 0 where a is not equal to 0. The rational polynomial equations such as px upon qx is equal to 0, etc. are the examples of the algebraic equation. The next type of equation is known as the transcendental equation, and that type of equation is containing the transcendental functions. The elementary transcendental functions are the exponential, logarithmic, trigonometric, reverse trigonometric and the hyperbolic function, such as 2 into e to the power x plus 1 is equal to 0 is a type of transcendental equation. 2x plus cos x minus 1 is equal to 0. That is another example of transcendental equation. Such as the logarithmic function connection like log base 10x minus 2x is equal to 12. A plus b sin x plus c cos x plus d log x is equal to 0. X square minus log base ex minus 12 is equal to 0. Those are all the examples of the transcendental equations. Now, if the function fx is continuous in the interval ab and if fa and fb are of opposite signs, then the equation fx is equal to 0 has at least one root has least one root lying between A and B. So let us suppose with an example the total problem, and here at first we will prove how many number of positive root and how many number of negative root are there, then what are the range where the root lie or belong to. Suppose that is an algebraic equation, x cube minus 3x plus 1 is equal to 0. Now as usual we know as the variable x has the maximum power, that is 3. So it has 3 roots. Obviously it has 3 roots. So x cube minus 3x plus 1 is equal to 0 is a cubic equation, hence 3 roots are there. Now we use the Descartes rule of sine. Once again the Descartes rule of sine to find how many number of positive root are there in the equation and how many number of negative root are there in the equation. And for that what we are doing, just that is the polynomial x cube minus 3x plus 1. So use at first positive x or the plus x in place of the variable x. Now when we are using the positive x, that means plus x whole cube, so that is becoming plus minus of 3 plus x, that means minus 3x plus 1. Now check at the change of sign. Here that is plus, here that is minus, and here that is once again plus. So that means there are two change of signs, from plus to minus and minus to plus, and we have used the plus x. That means here in the equation we have two positive root. Once again for the plus x there are two change of signs, so according to the Descartes rule of sine there are two positive roots. Now we use in place of plus x, that is as minus x in the polynomial. Now plus x cube, so plus of minus x whole cube minus 3 into minus x plus 1. So that one is becoming minus x cube plus 3x plus 1. So only one change of sign from minus to plus. So we have one negative root, as that is for minus. So in the equation we can find there are two positive roots and one negative root according to the Descartes rule of sine. Now we will find what are the ranges of the root. So we start from 0. That means in place of x we are putting the value as 0. So when we are putting the value x for 0, we know the equation is now x cube, once again x cube minus 3x plus 1, x cube minus 3x plus 1. So when we put the value 0 here, we get the result as only plus 1. So that is the result. That means that is positive for the value of the function. Now we put the value of x as 1. Now when we are putting the value of x as 1, that means plus 1, that is 1 cube minus 3 into 1 plus 1, or the result is minus 1. So that is minus 1. So that means that is negative. So when there are of opposite sign for the functions, when x is 0 and 1, as the functions are of opposite sign, so one root must lie in between 0 and 1. Next, we put the value of x as 2. So here that one is becoming 2 cube minus 3 into 2 plus 1, or the result is plus 3. Now once again we can check in f1, that means when x is equal to 1, the value of the function was negative minus 1. In the case of x is equal to 2, the value of the function is positive, that means once again of opposite sign. So another positive root must lie in between the x1 and x2, that means the range is 1, 2. So as usual, from the Descartes rule of sign, we know we have two positive roots. So the two positive roots are here belonging between 0 and 1, and another one 1, 2. But there is also another root that is negative according to the Descartes rule of sign. So we put the value of x as minus 1 here. So when we are putting the value as minus 1, so that one is becoming minus 1 whole cube minus 3 into minus 1 plus 1, and the result is plus 3. But at x is equal to 0, the result was plus. At x is equal to minus 1, the value of the function is also positive. So there is no root lying in between 0 and minus 1. Hence we put x is equal to minus 2. Now for minus 2, we have like that minus 2 whole cube minus 3 into minus 2 in place of x plus 1, and the value is now minus 1, that means negative. So f minus 1 at x is equal to minus 1, value of the function is positive, and x is equal to minus 2, the value of the function is negative. So there is a change of sign for the value of the functions when x has the values minus 1 and minus 2. So the negative root must lie in between the minus 2 and minus 1, and in that way we can find out the range of the root for any algebraic equation and also for the transcendental equation.